Hi everybody, it's Hazel and welcome back to another Ace Explains video. Today we're going to be going over right triangle trig and the six trig identities or trigonomic ratios that you can find in triangles. This is really helpful when you're taking geometry because those triangles, they're literally everywhere. So basically, I'm going to start by drawing a triangle. Granted, my drawing skills are not that good, so I'm going to warn you right now, this is probably not to scale, but here's my triangle, and I'm just going to start by putting an angle, and I'm going to mark that angle in red, but I'm going to start by putting an angle over in, let's go with this corner right here. And this will be marked by the Greek letter theta. So you'll notice in a lot of geometry classes that they're gonna mark the angle with the Greek letter theta, or they could use x, but it's usually gonna be theta or x. So this is theta, which is like a circle with a line across the center, and then of course you are familiar with x. But those are usually how they mark the unknown angle. And that just means that you don't know the measure of the angle, but you're going to be able to find the measure of the angle using the trig identities. So the I'm sniffling, I'm a little sick, but whatever. The six trig identities that you need to know are sine, cosine, tangent, secant, cosecant, and cotangent. It is very important to note that sine and secant, sine and cosecant are opposites, cosine and secant are opposites, and then tangent and cotangent are opposites. So those are the six trig identities. And then every trig identity has a ratio that is attached to it that has to do with the triangle. So we're going to go back to this triangle over here, and I'm going to show you some important things with the triangle. So in a triangle, in a right triangle that is, and this is a right triangle, and this only works with right triangles. So this is right triangle trig. But in a right triangle, you have your three sides. So you have the hypotenuse, which is right here, right? And then you have the side that is right across from the unknown angle. The side that's right across from the unknown angle is called the opposite, because it's like opposite to the unknown angle. And the side that is right next to the unknown angle is called the adjacent. So you have the opposite side, the adjacent side, and then of course you have the hypotenuse. And so these are your three sides that you can do in the right triangle, and they have to be across from the unknown, not across from the right angle, which is here. It's across from the unknown. Okay, I feel like that's really, really important to note. So the unknown angle is the one that's down here in this corner, and the opposite, the adjacent, and the hypotenuse are all built based on the position of the missing angle. So the first three trig identities are as follows. You have sine, you have cosine, you have tangent. Sine is equal to the opposite over the hypotenuse. Okay, so if you're saying the sine of this missing angle right here, it is equal to the measure of the hypotenuse divided by the measure of the measure of the opposite divided by the measure of the hypotenuse. So whatever number is at the opposite, let's say it's 5, and then let's say the hypotenuse is 11. So naturally the sine of that missing angle would be 5 over 11, since it's opposite over hypotenuse. Cosine would be adjacent over hypotenuse. So we have 5 here, let's say we have 7 here and we have 11, right? So the cosine of that missing angle right here, the unknown angle, would be 7 over 11, since it would be the measure of the adjacent side over the measure of the hypotenuse side, okay? And then after that, or lastly, you have your tangent, which is equal to, hold on, it's skipping me, opposite over adjacent. And so that's the measure of the opposite side over the adjacent side. So basically, hold on, I'm trying to get my examples up. I have examples. Okay. So basically, those are the main three trigonometric identities. And then of course you have the ones that are opposite to those, the secant, cosecant, and cotangent. So I'm just gonna copy this real quick. Oh, that's not what I wanted at all. I'm just gonna copy those real quick. And so you have secant, you have cosecant, secant, and then cotangent. I think there's a way to write cosecant that I was writing incorrectly before. There we go. You have the cosecant, the secant, and the cotangent. And these are the opposites, by the way, of the original identities. So like I said, cosecant is opposite to sine, secant is opposite to cosine, cotangent is opposite to tangent. And so, since we know the original three identities, we can use the reciprocal to find the other three identities. So starting with cosecant up at the top, it would be hypotenuse over opposite. We would have hypotenuse over adjacent, and then we would have adjacent over opposite. And these are the three other trig identities. And so these make up the 6 trig identities or ratios. Your teacher might have you say identities or ratios for right triangles. Okay, those are the 6. So now let's say you have a triangle. Now I'm gonna have to make sure this is a nicely drawn triangle and drawn somewhat to scale for this example. Okay, I think that works. Cut off the ends. All right, so let's say you have this triangle, and let's say, like in the other triangle that I made, that this is the unknown angle, and it is denoted by theta. And so let's say you have a right triangle with the measures 17, 15, and 8. Now, in my other examples, all the lines that I was using, or the measures of the lines I was using, did not ascribe to the Pythagorean theorem, which is bad of me, but you want to make sure that all your sides follow the rules of the Pythagorean theorem when you do this problem. And so remember the Pythagorean theorem, which I have a video on, I think. Theorem says that a squared plus b squared equals c squared. So you want to make sure that your side measures follow this rule. But aside from that, let's say that you have 8, 15, and 17 as your side measures, and you are asked to find the cosine of theta. So it will be written just like that. It will be cosine, or it will be the abbreviation of cosine, and then it will be theta right next to it, and they're asking you to find the cosine of theta. So remember, cosine is equal to opposite, adjacent over hypotenuse, right? And so you are going to find the adjacent, which is right here, and you're going to find the hypotenuse, which is right here, and you're going to stack them on top of one another. So the adjacent is 15, the hypotenuse is 17. So the cosine of theta in this triangle is 15 over 17. And they might ask you to leave it as a fraction or to rewrite it as a decimal. And that's, like I said, your teacher's choice. That's, I don't know. Every teacher's different. Let's try another example. Let's try and find the sine of theta. So sine is equal to opposite over hypotenuse, right? And so that's gonna be 8 and 17. So you're gonna write 8 over 17, and that is the sine of theta. all right? And it's the same for all the other trig identities. So tangent, right? Tangent of theta. Tangent of theta is opposite over adjacent. So what are you going to do? You're going to look for the tangent. You're going to look for the opposite, and you're going to look for the adjacent, and you're going to stack them on top of each other, just like the trig ratio says to do. Just like that. So you just follow the order of the trig ratio. So the only thing that you need to know in the triangle is you just need to know the opposite, the adjacent, and the hypotenuse. And you need to memorize the ratios for the 6 trig identities. Once you know all of those, then it's really, really, really easy to just plug the numbers in to where they go. Basically, it's just about plugging the numbers in to the spaces where they go based on their name. So let's try some more examples. In this triangle, we have an angle marked by theta, and we have the measures 11 and 6, right? Oh wait, that's actually not gonna work because we don't have all of the angle measures. I messed up and I found the wrong type of problem. That's my bad, okay. Hold on. Okay. All right, so let's use this instead. So we have a triangle with the measures 3, 4, and 5. And let's say I ask you to find the tangent of theta, right? So what would you do first? You would find actually, I don't think you would find. You would start by remembering, what does tangent mean? Well, if you remember correctly, tangent means opposite over adjacent. Opposite over adjacent. Now you're on the hunt to find the number that is opposite to the angle and adjacent to the angle. So that's 4 and 3. Opposite over adjacent. And that is the answer to the tangent of theta in this triangle. Let's challenge ourselves and find the cosecant of theta. Now remember, the cosecant is opposite to what trig identity? That's right, it is opposite to sine. That's a terrible way of writing that. It is opposite to sine. Because of this, we're going to do the reciprocal of the sine ratio. So the sine ratio, remember, is opposite over hypotenuse. That means we are going to flip these two, and it's going to be hypotenuse over opposite. Now, what does this have to do with cosecant, you ask? Because cosecant, and this is something you have to memorize, but because cosecant is the opposite of sine, then we use the ratio for sine and we find the opposite of that ratio. So we just swap the two numbers, or we swap the two identities, I guess. So we now have hypotenuse on top of opposite because cosecant is the opposite of sine. So we now find the hypotenuse, which is 5, and we find the opposite, which is 4. And our answer is going to be hypotenuse over opposite, 5 over 4. Okay, so that's basically it. And then of course, this rule works with all 6 of the trig identities as long as you can just recognize what they are and you'll be able to do it. Let's try one more for good measure. Let's try cotangent. Cotangent of theta, remember, cotangent is opposite of tangent. the tangent identity is opposite over adjacent. So the cotangent identity is going to be adjacent over opposite. We find the adjacent, which is 3. We find the opposite, which is 4. And that is our cotangent of theta. Okay, so I hope this made some sense for you guys. Yeah, obviously sound off in the comments if you want like a better explanation, I guess. I can always do a second video or do more example problems, but I hope that this makes sense for you guys in terms of how to factor right triangle trig problems, and I'll see you guys next time with another Ace Explains video. Take care, guys.